So we like to learn what are the factors affecting equilibrium constant. So the first question that we have set of questions to answer factors affecting equilibrium constant. Does Kc depends on concentration? Because Kc involves the formula. Kc involves concentration in its formula. If molarity of reactant or product changes, will Kc change? Does Kp depends on partial pressure? If partial pressure of reactant or product changes, does Kp changes? What are the other factors affecting Kc and Kp? These are a set of questions that we would like to answer now. First, does concentration affects Kc? The answer is no. Concentration doesn't decide equilibrium constant. It decides its value, but it doesn't decide Kc. Okay, what do you mean by that? If reactant's concentration will change, then product concentration also will change accordingly as per Le Chatelier principle, so that the Kc value remains constant. Similarly, if product concentration decreases, reactant concentration also will decrease to keep the value of Kc constant. That means concentration or a molarity, more popularly known here, will not decide Kc. It decides only the value, not Kc. So once the Kc value is calculated, whatever is a different concentration of product or different concentration of reactant, Kc value will remain same. So Kc value doesn't change with change in concentration of reactant or product. Similarly, does pressure, partial pressure, decides Kp? Answer is partial pressure decides value of Kp. But if partial pressure changes, does Kp changes? Answer is no. Kp remains constant. So scientifically, we say pressure decides value of Kp but does not decides Kp. It decides value of Kp but doesn't decide Kp. Why? Because if partial pressure changes, Kp still remains constant. It's like that. If partial pressure of product is changed, then partial pressure of reactant also will change accordingly to keep the Kp value constant. What you are able to see, the power P and R are nothing but the stoichiometric coefficient of the product, stoichiometric coefficient of the product and stoichiometric coefficient of the reactant. So again, conclusion for us, concentration and pressure decides the value of Kc and Kp, but Kc and Kp doesn't change with change in concentration or pressure. So we say scientifically Kp and Kc are independent of concentration and pressure. So what are the factors on which Kp or Kc depends? So we have a formula, equilibrium constant is A multiplied by E to the power minus delta H by RT. The constant A I have just written as B for convenience. So the next formula that we are going to popularly remember henceforth is the constant A has been changed to constant B and the same formula has been remembered. So equilibrium constant K is B e to the power minus delta H by RT. The constant B depends on nature of reaction. Delta H also depends on heat of it's called as heat of reaction and depends on nature of reaction. And T stands for temperature. So what are the factors on which equilibrium constant depends? It depends only on two factors. One factor is nature of reaction and second factor is temperature. So equilibrium constant depends only on two factors, nature of reaction and temperature, and does not depends on concentration and does not depends on pressure. So equilibrium constant doesn't depend on concentration or pressure, depends only on nature of reaction and temperature. So K depends only on temperature. That's what is our conclusion. And this formula tells you that equilibrium constant, how it depends on temperature. So how does K depends on temperature? Answer is exponentially. So relation between K and temperature is exponential. Whenever you have an exponential relation, it is best to convert this into logarithmic so that it becomes easy to understand. So we take log on both the sides. If you take log on both the sides, the multiplication between B and E will become plus, and the power which is there of E will become multiplication factor. So minus delta H by RT it will become. This is what will happen. Then what next? Then log E value is known in the world. What is value of log E in the world? 1 upon 2.303, and log of 10 to the base E, the value is 2.303. Remember, log 10 to the base E value is 2.303, and log E to the base 10, the value is 1 upon 2.303. Reciprocal of that. We want the value of log E. We want the value of log E. If you want the value of log E, then it will be 1 upon 2.303. So log of K is equal to log of B plus minus delta H by RT upon 1 upon 2.303. So log of K is log of B plus minus delta H by 2.303 R, and 1 by T has been taken out as a separate. Now who are the variables in this? Variables means if you change one, the other also will change. K changes with temperature. So for us the variable is K and 1 by T. So log of K will be taken as Y coordinate, and fundamental quantity 1 by T will be taken as X coordinate. So one will be Y, other will be X. 1 by T will be taken as X. So what type of graph will be there between log of K and 1 by T? Naturally, right, log of K is a Y coordinate and 1 by T is X coordinate. The number associated with 1 by T is slope, and something which is independent of 1 by T is nothing but y-intercept. That means if you plot a graph of log of K versus 1 by T, it will be a straight line. In this straight line, the slope will be minus delta H by 2.303, and y-intercept will be log of B to the base 10. If you plot a graph of log of K versus 1 by T, then the graph will be straight line, not passing through origin. Now we go ahead. Heat of reaction. For exothermic reaction, delta H is negative. For endothermic reaction, delta H is positive. So if you go it for endothermic reaction, where delta H is positive, slope is minus delta H by 2.303 R. So if you calculate, if you put delta H as positive, here the slope will be overall negative. So if you plot a graph, the graph will be a straight line. Graph will be a straight line, not passing through origin and making obtuse angle with the positive direction of x-axis because the slope is negative. Lines making negative slope will make obtuse angle, and the y-intercept will be log B to the base 10. Now if you analyze this, as 1 by t is increasing in this direction, then log of k is decreasing. So log of k value is decreasing. If log of k value is decreasing, k is decreasing. So if 1 by t is decreasing, log k value will increase because they are inverse to each other. That means k value will increase. If 1 by t is decreasing, that means temperature is increasing. So conclusion is, as temperature increases, K increases. So conclusion for endothermic reaction, as temperature increases, K increases. Higher value of K is hence possible at dash temperature. That is at higher temperature. So higher value of K is possible at higher temperature for endothermic reaction. For exothermic reaction, delta H value is found to be negative. So slope which is minus delta H by 2.303 R will be found to be positive. If slope is positive, the graph will be like this, which is not passing through origin. So if you find out what type of angle does it makes with the positive direction of x-axis, it makes acute angle. So type of the line it makes is acute angle because the slope value is positive. If you analyze the graph, 1 by t is increasing in this direction. So if 1 by t is increasing in this direction, log of k is also increasing. So log k value increases with increase in 1 by t. That means k is increasing. That means if 1 by t is decreasing, k, log of k will decrease and k will decrease. But for 1 by t to decrease, temperature should increase. So as temperature increases, k decreases for exothermic reaction. So for exothermic reaction, if you want high value of K, then it is possible at lower temperature. So high value of K is possible, at lower temperature because they are inversely proportional in the discussion. Overall conclusion, equilibrium constant depends on temperature and nature of reaction. For endothermic reaction, as temperature increases, K increases. For exothermic reaction, as temperature increases, K decreases. Remember, for endo, right, it is increases with increase in temperature. For exo, K decreases with increase in temperature. We are all aware, as a human being, we are highly selfish. That means in any reaction where reactant is becoming products, we always wish to have more products. That means we always wish to have forward reaction. That means we always wish to have higher value of K. For higher value of K, for endothermic reaction, we require high temperature, and for exothermic reaction, for high value of K, we require low temperature because relation between temperature and K is different for exo and endo. That means endothermic reactions are favored at high temperature and exothermic reactions are favored at low temperature. Similar conclusion has been drawn in Le Chatelier principle 2, that endo are favored at high temperature, exo are favored at low temperature. One more information for you. If temperature is T1, equilibrium constant is K1, and if the temperature is T2 and the equilibrium constant is K2, then log of K2 upon K1 is given by the formula delta H 2.303 R 1 upon T1 minus 1 upon T2. This way we will be able to find the value of delta H if we are aware of delta T1 we know K1, at T2 we know K2. If you substitute all these values, you will be able to calculate delta H. Similarly, we will be able to use this equation to calculate K2, that is equilibrium constant at any other temperature T2. If you know K1 T1, that is equilibrium constant at temperature T1, and delta H. So that was a small discussion of equilibrium constant versus temperature.